Now we're going to solve this same system of linear equations using the substitution method. And the substitution method says that you pick either equation you want and you solve that equation for one variable. Whichever variable you choose, but I'll choose y. And I've solved for y now, and I got that it is negative x plus 3. Now what you do is you take that equation and you plug it in for that variable that you solved for in the other equation. So I'm going to write down the second equation, except I'm going to replace this y with negative x plus 3. If we distribute the negative through the parentheses and combine like terms, we can add 3 to both sides and then divide both sides by 3. And this gives you x equals 1. However, this is only half of the solution because we need both an x and a y value to solve a system of two equations and two unknowns. So to find what y is, we can take this x equals 1 and plug it into either equation, doesn't matter which one. I'll just choose the first equation, x plus y equals 3. I'm plugging in x equals 1, and we get y equals 2. Now, x equals 1, y equals 2 is the solution to this linear system of two equations and two unknowns. And we typically write that solution as an ordered pair. Okay, let's do this one more time with another example. This one's going to be slightly more complicated. Now again, you can choose either equation to solve for either variable. Sometimes the appropriate choice can make your life a little bit easier. I'll just pick the first equation and I'll solve for y. So I got y is negative 2/3 x plus 2. I'm going to take that y and I'm going to plug it into the second equation for y. And we get a bit of an ugly mess right here. Fortunately, we know how to solve these linear equations. We're going to distribute through our parentheses. Negative 4 times negative 2/3 is positive 8/3. Negative 4 times positive 2 is negative 8. I'm going to add 8 to both sides. And now we need to combine 2x and 8/3 x. We need a common denominator for that, so we change 2 into 6/3. We now get 14/3 x equals 7. If we multiply by 3 and then divide by 14, now we can reduce by dividing everything by 7. I'm getting x is 3/2. To figure out what y has to be, I'm going to plug x equals 3/2 into either one of these equations up here. I'll just choose the first one. 2 times 3/2 is just 3. I'm solving for y now by subtracting 3 from both sides. I'm getting y equals 1. So the solution to this linear system of equations is the point 3/2, 1. Alright, in the last video I told you that there were 3 possibilities for types of solutions to these problems. There is one solution to this problem here, just one point. I want to explore the other possibilities starting with this example right here. I'll go ahead and use substitution. I will take the first equation and solve for y. Then I will take the result that I got there and plug it into the other equation. When I do that, my 2x and my negative 2x are going to cancel, and I'm just going to be left with 3 on the left side, and we still have a 4 on the right side. Well, 3 equals 4 is not true. It's a false statement. And when we get this to happen when we're solving systems of linear equations, that just means that we're going to have no solution. And if we think back to what that means on a graph, well, what we started with were 2 parallel lines. You could graph both of these, and they are parallel lines. They have the same slope and just a different y-intercept. Okay, last example, I promise. I'm going to do the same thing. I'm going to solve the first equation for y. I'm going to plug it into the second equation for y. I'm going to distribute the 2 through the parentheses. And I'm going to notice that 4x minus 4x cancels, and we're left with 10 equals 10. This here is a true statement with no variables left in it. And what has happened here is we found the case where we have infinitely many solutions. We started off with 2 lines that were exactly the same line. And you can see the trickery that I pulled here. I just took the first equation, the first line, and I just multiplied both sides of the equation by 2 to get the second line. So technically they're the same equation. We have 2 completely overlapping lines, so we found ourselves infinite solutions. Okay, that's all I have for you for substitution. In the next video, we're going to talk about another technique called elimination. And I'm not saying that one's better than the other, but elimination is going to make the algebra in this example right here much easier than it was in this video. So I'm a big fan of elimination. I'll see you there.